Alrighty, so 7.8, this is that abbreviated assignment stuff. So this count equals 0 and then count plus equals 1 means that I'm going to take count, whatever is over here on the left, and add 1 to it, and then put it back in there. So instead of writing count equals count plus 1, you could make it shorter by saying count plus equals 1. I'm not really worried about it, and all. It's not something I use much. It's good though that you just realize it's there. So if you're reading something and see that plus equals, you got an idea of what it might be doing, and then you can always look it up for that particular language if you need to. Same things for those, and then. Here just talks about the description of things and so forth. And this is actually from an earlier video. I hadn't noticed this. I tried to just do something like range 10 to get this 0 through 9, but you actually have to put list around it, and then it does that. But so that's a range of something makes a list. So not too worried about 7.9. Now tables, yes, this is more about some printing output in a nice fashion. And so here they're just they're using this tab character, so it's a \T. So the backslash tells you that it's something that it's telling the computer to do. And in this case it's a tab, and so you can look things like that, look up characters like that. Usually you look under the print statement and look for that kind of stuff. But here, yeah, so they're going to use a tab, so they're going to print X and then use a tab to move over, and that that can be any, that I don't know that there's a set tab size or something for any given program or anything like that, but so yeah, let's copy that and I'll put it in over here, and if we just run this, we get their output that they had, and that's really nice. It's very, very readable, as opposed to, right, if we did this instead. Okay, so here's what we kind of knew how to do before. So and it looks fine until we get to the 10, and then it kind of shifts things over and it's harder to read, so not as nice. So yeah, using that tab character can be very handy. So we'll put that back the way it was. Go ahead and get rid of this. And so they're just pointing out you could use this tab character, and so they did that application. Now I'm going to toss in 7-Eleven with this because it was that quick to do the tabs. So here they're showing this use of end again, and so what they're going to do is they just want to print the times tables. And they, in this case, notice when they said range, they didn't just say 7, they said 1 to 7. So they made sure they started at 1 and not at 0. And we just want to look at things that go sideways here. And so they're using a certain amount of space between things. And so that's, they call that a two-dimensional table. So yeah, you know, the point is that they didn't put the end on it here, and then they put print at the end with nothing in it, and that's what gave them a line feed. Okay, so they that was easier than trying to put in the logic with a, you know, say spaces to begin with, and then the last one put in the carriage return line feed. And so, you know, this is another way to handle it, is you just, you know, this is after this last print of 12, the thing's about right here, and but then that print statement brings you back over here to the left, because a normal print statement always executes and then comes back over to the left one line down. So yeah, let's toss this in. And I just want to see something here. Yeah, so we'll go on then to 712. I was thinking that's what we would want to do. Let's insert a cell down below. And if we run this one, we should get their output. Okay, and the question is, you know, is this going to work well? Because suppose I want to do this for some other numbers. Well, and you know, so they didn't use the tab. We could have used a tab in between these, I believe. So let's try that. So what happens if we replace these, I don't know, 3 or 4 spaces by a tab? And we run that, and it spreads them out more, but yeah, that works. You know, so put a tab at the end of each of those numbers. Okay. So, you know, that's all they're really talking about there. They use that special end command again within the print statement. And so here it says they made a definition out of this of print multiples of n. And so, okay, yeah, that's what we'll do. We'll change that into a definition. So I'll just copy it here instead of doing all that work up there. Okay, so there's our definition. Now if I run this, it'll just be running this same thing again here, because I never call that definition. But if we look to see what they did here, now they're going to put each row into a loop of print multiples, and they make this two-dimensional table. And so it's interesting that notice how it lined up nicely. So even though this one had more space than that, it seemed to do okay with it. And actually that surprises me. Let's go back real quickly and just see what they say here about the ends. Again, the extra ends argument presses the new line and uses 3 spaces instead. After the loop completes, okay, so it says it uses 3 spaces. Well, then if that's if that's 3 spaces, then that should only be 2 spaces, because to get a lineup like that. So I don't know. Let's try it out. Let's see if our output looks like theirs. And so I'm going to get rid of that. And so we're going to get all the multiples there of 7 by 7. So let's run the cell. Yeah, see? That's what I'm talking about. Their output is not the right output for this particular program. So, that's where, looking at things and thinking about what they really do can kind of help. So, this would be very frustrating to me to see them do this and not realize, if I didn't realize, it really shouldn't look like that. And then when it doesn't, I'm not surprised. And so, in this case, this is where a tab might come in much handier. So if we do the tab, let's see how that looks. And that looks more like what they have. So it's interesting that their output looked like that. Not sure what's going on there. Okay. So though, it let I equal 1 and came in here for the definition for 1, and so it took 1 times I, or 1 times 1, and then 1 times 2, and 1 times 3, and up to 6. And we do it here as well for each row. So that's kind of nice, making a nice table like that. But tab, if you're really trying to get them to line up, tabbing is probably the way to go. Okay, so sometimes if you get frustrated because you can't get something to look like what the authors of a textbook did, well, you might want to step back and ask, well, should I be getting the output that they have? And in this case, no, we shouldn't have been, and we didn't. But we could fix it up by using a tab. And so one last thing here with the 7.13 or 713 is they say let's take the code from the last section and wrap it up in a function. Okay, so they just made another function that called the first function. Okay, so if you look at this, well, let's do it that way, actually. Let me hit enter. Enter. Okay, let's define, and I do need that name. There we go. And then all they did was they took this and made it part of that definition, like that. And so now, though, we would have to still call that, and so we would have to do print mult table of 7, and it should work with our two definitions there. Oh, it did not work. What just happened? Print multiple table, it says takes 0 positional arguments. Oh, okay, yeah, that's true. They didn't use an argument, so we just don't pass it an argument. So we just call it like that, and it will just do it. Yeah, I didn't think about it. Here we needed n, but here they just wanted to do it. But in the end, what would really be good is to pass, so let's put an n in here as well, and let's do our range from 1 to n. Okay, and then when we call this, let's now change this to be n comma I, and so here we need comma I, let's see, and so then when we come in here, so if I give it a 7 again, it comes in here and says do from 1 to 7, and then print, though I need to, it's going to wanted to print the 1. It wanted to do it with the 1, but I don't know how far to make it go, because I would like it to be square, and so that's what putting an N there would do. And so now let's try that with 7. See if I got that right. Oh, look at that. Not what I expected, huh? So it did the same table multiple times. So let's be careful about definitions of local variables and so forth. Oh, I see. I sent through I right here. I don't want I. Let's see, before it was just the N, and I gotta think about this for a second. So you see, you know, I mean, and this is okay. You know, you look at things and you have to think about them for a minute or a second. I said first, but no, it's going to take longer than that. It'll take a minute. Okay, so what I can do is I can put this back the way it was, like that, and this was the I here, and so, and I just need to make sure this N had to do with that range. Did I put it back right? Let's check. Oh yeah, no I didn't. Yeah, so that could be part of my problem. Let's go back here. So this was I. So definition print multi-table I. Okay. Oh, right, yeah. So I didn't put it all the way back to everything. And that needs to be a 7. Okay, so run cells. Oh, and I didn't want that N there, did I? 7. Okay. There, I got it back to where it was. Now I need to be a little more careful about how I do this. So let's think about this. Okay, what I want to do is I'd like to put a 7 here, and so that means now I need a variable here, but that means I would like a 7 there, and so then what I like to do here is the N, okay, but then actually tell it that this number is a 7. And so that does need to be an I here. But let's work from this end. So I'll call this, I don't know, K, and we'll put a K there. And then here, oh, I needed to tell it 7, right? And so here I can use, I'll try the N again, like this, and let's see if I got it to go this time. And there it is. Okay. So, you know, I had to back up and be very careful about where I wanted that 7 to show up, and the fact that, oh yeah, this N had to do with printing the multiples here, and so I got that to do that for any size. So there's 7, and I could do 12, and it gives me the 11 times tables here, I guess. to 11 times 11 anyway. Okay. So that gets us through 7.13, and that's enough for this video, I think.